This is the second episode of the podcast, Young Voices for Climate Action, part of Twinning Project, SDJ, Eco Voyage, Europe's Green Quest. Today we welcome Nicolas, Simone, Matteo, Lorenzo, Francesca, and Federica as the young voices who are going to ask our invited experts everything related to climate change and its most relevant effects on our everyday life.
Today we're still joined by Dr. Gianandrea Mannarini, a physicist and senior scientist at the Euro-Mediterranean Center on Climate Change in Lecce, Italy. He's a climate expert specializing in numerical applications for operational oceanography, dedicated to advancing public outreach and ocean literacy. Welcome, Dr. Gianandrea Mannarini. First of all, it's right and proper to thank you for your passionate analysis of climate change phenomena in the first episode of this podcast series, named Young Voices for Climate Action.
Thank you for this engaging voyage we are doing together through the functioning of the Earth system and the ways it is being reshaped by human activity.
During the second episode, it's clear that you are eager to know about possible scenarios for the future, that is, our future. And of course, we as younger generation are much more involved than any other generation.
Absolutely. I hope I can help you.
And now, let's start with our first question about a possible prediction for the oncoming years or decades. Over to you, Nicolas.
Dr. Mannarini, during our previous interview, you gave us clear analysis of the main hazards due to climate change. So, what scenarios can we expect in the next 30-50 years in the Mediterranean and in Europe, considering the current climate trends?
If present trends persist, we can anticipate a future of warmer seas and rising temperatures. In the Salento Peninsula, where warming currently tracks at half degree Celsius per decade, the sea could stand 15 to 30 centimeters higher in the next 50 years. Though the projections for total precipitation suggest a decline in the whole Mediterranean region, the added heat and humidity from the ocean will likely act as a fuel, increasing the frequency of extreme weather events. We have seen examples of these in the flooding in Emilia-Romagna, with 6,000 evacuations, or in Valencia, with over 200 deaths in 2024, or also in Derna, Libya, in September 2023, where more than 5,000 died due to the collapse of two dams, which led to sweeping away entire buildings, the deadliest rainfall-related flooding disaster since the late 70s. All these events occurred in autumn, when the Mediterranean Sea is still warm after intense summer heating, but cold spells aloft can trigger atmospheric instability. It is expected that these events will become more frequent, more intense, and more widespread as the sea surface temperature increases.
If present trends persist, as you said before, it is clear that our seas are under very special surveillance. So I would ask you, what is the current rate of eustatic sea level rise?
The global mean sea level has been instrumentally monitored for centuries now, initially just via tide gauges at coastal sites, and since 1993, also from space via satellite altimetry for the whole ocean surface. The data hint to a rise of about 20 centimeters in the past century, and about 11 centimeters during the past 3 decades. Also, at the beginning of the satellite era, the rate of growth was about 2 millimeters per year. Today, that rate has doubled. As the growth depends on both water warming and land ice melting, scientists find that this acceleration is related to the increasing melt rates of the ice sheets. it is important to note that the global rate does not match the local rate, especially at coastal sites. This relative sea level rise depends not only on the vertical land movements, such as the subsidence due to hydrocarbon extraction or the rise of the land due to the post-glacial rebound, but also on local meteorological and oceanographic processes. Thus, we see a decline of the relative sea level in parts of the Baltic Sea and a fast growth in Southeastern Asia. The situation in the Mediterranean is somewhat distinct, with sea levels rising more slowly than the global average. In this basin, the expansion of warming seawater is countered by high evaporation rates, which increase water salinity and density. As a result, the rise we observe in the Mediterranean Sea is mainly due to the influx of water from melting ice sheets elsewhere on the planet.
And actually, considering that relative sea levels are generally rising in the Mediterranean, how many centimeters of horizontal coastline are lost for every centimeter of sea level rise?
That depends a lot on the type of coast. For a sandy beach, the shoreline recession is given by the amount of sea level rise divided by the slope of the beach. For example, with a 3% slope, each additional centimeter of sea level rise translates into about 30 centimeters of recession. The flatter the beach, the larger the recession. The actual recession may even be larger, as the slope should be evaluated on the active part of the beach, which includes a submerged part down to the depth where waves finally lose their ability to shift sand back and forth.
Dr. Mannarini, speaking about the oceans, we know that they have a large thermal inertia. At this point, I would ask, even if we reduced emissions to zero today, for how many centuries will sea level continue to rise due to the heat already accumulated?
First, it is important to realize why there is an inevitable future increase in mean sea level locked in by past emissions. One reason is that we cannot prevent the heating of the ocean from proceeding from the surface layers towards the depths. This heat will contribute to erode subsurface ice shelves, what is called basal melt, leading to the melting of the ice sheets above them. Another reason is that many glaciers are already right now out of equilibrium. This means that they cannot be stopped from melting, even if we were to remain in our present climate situation. That said, scientific reports usually do not frame the answer in terms of how long sea level rise will continue. Instead, they focus on the committed sea level rise, expected by a specific point in future. This approach highlights the amount of rising sea levels that is already inevitable due to our past emissions. So, if we could zero emissions overnight, we would likely stabilize global warming at about 1.5 Celsius. According to the latest IPCC assessment report, that would limit sea level rise to roughly 30 to 60 centimeters by the end of this century. Please keep in mind that this is the best case scenario we are fighting for, so if we limit global warming to 1.5 degrees. Instead, with 2 degrees of peak warming, a rise of 2 to 6 meters would follow, within the next 2,000 years. There are large uncertainties on this value, though, due to the fact that we don't fully know how fast massive glaciers will crumble once they start. For instance, in Antarctica, tall ice cliffs, once they lose their supporting ice shelves, could collapse under their own weight, dramatically accelerating sea level rise. What we know from ice cores and paleoclimate records is that the last time the planet had about today's mean temperature, during the last interglacial, 120,000 years ago, the ocean level was 6 to 9 meters higher than today. It may take 10,000 years to melt all that ice, or perhaps just 2,000 years, with 3 Celsius of peak warming. So there are 2 urgent goals for our society. First, immediately slash greenhouse gas emissions to slow the process down, buying time for coastal cities to adapt. And second, keep investing in science. This is the only means to close our knowledge gap and determine how much time we have left to move, rebuild, or protect our shores.
Considering the possible scenarios you're disclosing here, it's clear that there is not much time left and that so many hot tasks have to be accomplished by all of us, urgently. But now, it's obvious to wonder about the possible risks and adjustments we can face in our everyday life in order to survive. Over to you, Federica and Francesca.
Thanks, Estelle. Dr. Mannarini, when we talk about climate change, we often focus on environmental impacts. But what about human health? What are the risks that are still underestimated or not receiving enough attention today?
First, let me please clarify that climate action is urgent, but it is not a race. It looks more like a long-lasting effort where we cannot remain at the starting line, but we have to consistently act over decades and generations. So please do not waste all your concern now. Keep at least a part of it for the next 10, 20, or 30 years maybe, when, due to your professional status, you will possibly be in the position to shape the destiny of our society. However, we should know that women and elderlies are the most affected by prolonged heat waves. For instance, a 2025 study by Janosch and et al. Found that in the summers of 2022 to 24, heat waves in Europe resulted in approximately 100 additional deaths per million inhabitants for every degree Celsius of surface temperature anomaly. Furthermore, we must consider the risks from tropical diseases. Warmer temperatures and longer warm seasons favor the survival of vectors like mosquitoes and extend their transmission window. A specific risk in the Mediterranean region is represented by dengue, which is starting to appear outside of its endemic areas on other continents. Since 2010, West Nile virus, a mosquito-transmitted virus that can lead to lethal neurological disease, has been reported in southern Europe, where we live. The warming climate also led to longer flowering season of plants that release allergenic pollen, and this was anticipated by 1-2 weeks, increasing the risk for allergic rhinitis.
And what about key human activities like agriculture? Are we still in time to preserve traditional farming as we know it, Or will climate change force us to fundamentally rethink how we grow food?
In Southern Europe, actually, we haven't seen a huge drop in total rainfall over the long term yet. A comprehensive study on nature published at the end of 2024 proves it. However, it is getting drier. This happens as the heat increases evapotranspiration from trees and crops, and the warmer atmosphere can hold more moisture, displacing it from the soil like a sponge. If we stay on this high emissions path, the models tell us that the rain will eventually start to fail us here in this part of the world. There are projections showing how the yields of main crops may change in the future warmer climates of the Mediterranean region. For winter wheat, no major changes are currently expected, and its yield could even increase if the traditional rain-fed systems are supplemented by irrigation. For maize, instead, a major yield decrease is projected. Crucially, the studies suggest that this decline will likely not be offset by irrigation because of the physiological limits of the plant under extreme heat and the increasing scarcity of water resources in the region. It is interesting to note that wheat matures before the most extreme summer heat hits, whereas maize is a summer crop. Maize is important not only for human nutrition, but also as a vital livestock feed and a primary feedstock for the chemical industry. Because of these diverse uses, a decline in maize yields would have ripple effects across our entire economy.
In conclusion, Dr. Mannarini, considering that we are now witnessing extreme climate phenomena like heat waves, droughts, floods, and cyclones in the Mediterranean region, we would like to ask whether these hazards are clear evidence that we have reached a point of no return.
No, I don't believe they are. We now have plenty of evidence confirming the link between heat waves, floods, and global warming, just as was predicted by scientific reports. But it is important to realize that these are still amplifications of our current climate. They are signs of stress, but they are not points of no return yet. As we explored during the previous episode, tipping points are a different and much more worrisome story because they represent a permanent break from the climate we have known.
We would like to thank our audience for following the discussion on the impacts of climate change. Recognizing these consequences is a crucial step towards meaningful action. Thanks to Dr. Mannarini, who will be with us in our next episode of the podcast series, and will consider potential solutions and strategies to mitigate and adapt to climate changes.
Sure, I'm eager to take your next questions.
Thanks, Dr. Mannarini.
And see you again for another pleasant talk together.
Bye-bye.